All right, guys, here we go. Kind of building off the last video of completing the square and graphing quadratics. Um, this one is just going to go over end behavior for the graph of any polynomial. All right, so you can take that down for the objective. So we're going to look, what does the graph do when we go all the way to the left and all the way to the right? So that's what end behavior means. Now, polynomial, we'll build off the quadratic from the last video, where we might look at graphs or equations where the degree is 3, 4, 5, 6. I could have something, an x raised to the eighth. And just by looking at the equation, I'm able to tell what the graph does as I go all the way to the left and all the way to the right. So to kind of basically figure that out, I have these four equations right here where we start with a degree of 1 to 2 to 3 to 4. And I know if I graph, like this would be a line that goes up left to right. So this end behavior to the left, it goes down. To the right, it goes up. So that's what we mean by end behavior. For number 2, it's just our basic parabola, and both ends go up. For 3, we have an S curve, and that's just like number 1. To the left, it goes down. To the right, it goes up. And if you were to graph y equals x to the fourth, it's going to look a lot like the quadratic, the y equals x squared, except it kind of like flattens out, but the end behavior is all the same. All right. So hopefully you kind of see the pattern there. If your degree is even, then they're both going to go up. If your degree is odd, like it is here for 3 and 1, you have one side is down and one side is up. Now, if I put a negative in front, like if I did y equals negative x squared, then it would flip and then they both would go down. All right. So you could just look at the equation and know what the ends of the graph look like right away without doing any math. All right. So really, just to sum this up, this should be real quick. I kind of mentioned it. If your degree is even, and the leading coefficient's positive, this is like the example for y equals x squared or y equals x to the fourth. This is your end behavior. They both go up. They go up to the left, and they go up to the right. If leading coefficient is negative, well, it's just like the negative x squared. It flips over the x-axis, so now they both go down. If your degree is odd, and the example we used was the y equals x cubed, that's the S curve. If the leading coefficient is positive, to the left it goes down, to the right it goes up. If you make the leading coefficient negative, that's where the S curve flips, and to the left it goes up, but to the right it goes down. All right. So really, I'm hardly using any math right now. So if I did some problems, if you look at these 7 problems, I have polynomials, and I'm just going to put the arrows and describe what happens as you go to the left, and then what happens as you go to the right. So 1, 2, 3, and 4, you can see they're all written as polynomials. You just look at the highest exponent. So number 1, the highest exponent is 4, and it's positive 1x to the fourth. So these are both going to go up. For number 2, they try to disguise the leading coefficient, but the highest degree is this 5. But then since it's negative, it's going to be like the S curve that's flipped. So to the left it goes up, to the right it goes down. Right? And I know this without even plugging in values for an XY chart. For number 3, the highest exponent's 3, leading coefficient's positive. So this is going to be like a normal S curve, where to the left it goes down, to the right it goes up. For number 4, the degree is 4, but the leading coefficient's negative. So it's going to be like an upside down parabola. So these are both going to go down. All right, that would probably take you like 5 seconds to do each of these. Now, 5, 6, and 7 takes a little bit longer, not that much. But 5, 6, and 7, these polynomials are factored out. So no, we don't have to FOIL all these out. That would take forever. Now, all we have to figure out is what is the leading coefficient and what is the degree. Now, if you look, if you did FOIL this out, you have this 2 right here, and this is a 1. So if you FOIL that out, you would get x cubed, and all these x's are positive. So you would get a leading coefficient of 1, and it would be x cubed. So this would just be the S curve. It would go down to the left and up to the right. For number 6, you can see that they're both squared. Now, if you FOILed those out, you would get x to the fourth. Now, you might think that, oh, you're going to have negative x to the fourth, but when you square this negative x, it's going to still give us positive x squared. If you square that, that'll give you positive x squared. And when you multiply those out, it gives you x to the fourth. So this is going to be just like a parabola where they both go up. Okay, number 7. So you can see when they're factored, you're kind of just adding the exponents. For number 7, these are both cubed. Now this one, if you have a negative x and you cube it, since you're raising it to an odd power, it's going to stay negative. So it's going to be negative x cubed. And then this x, if you FOIL all this out, it's going to give you x cubed. When you multiply that, you're going to keep the negative. That's negative x to the sixth. All right, so this is going to be, it's an even power, but it's negative. So it's kind of like the parabola that's flipped. So these are both going to go down. All right, so this video kind of gives us a precursor of when we have polynomials and the degrees are much bigger, like 4, 5, 6, 7, or 8. We can tell just by looking at the degree and the leading coefficient, we can tell what the ends are going to look like to the left and to the right if they go up or down.